Cape Rea on Morocco's Atlantic coast. Ocean rollers smash into the African continent from the open sea. Jagged rocks fend off the waves, as if to say, to here, but no further. Chemical erosion transforms the surface of the limestone into a bed of nails. This rock dates back to the era of the dinosaurs. Hard to imagine that this stretch of coast is just 20 kilometers north of the idyllic sandy beaches at Agadir. Few of the millions of tourists who flock to Agadir every year know that they're spending their holiday close to a very unusual natural spectacle. When the wind gets up, the coast of Cape Rea suddenly comes alive. A powerful jet of water is forced under enormous pressure through a hole in the rocks. Fountains of seawater shoot out of the ground at regular intervals. They're known as blowholes, a natural phenomenon reminiscent of geysers, however in this case not related to any kind of volcanic activity, but a result of the pressure of the breaking waves on the rocks. Blowholes of this quality are rare, and you'd have to go to Australia's west coast or Tonga to find their equal. The natural fountains of Cape Rea can only work because of the cavities in the rock. The aggressive seawater has gouged out existing cracks and etched small tunnel systems into the limestone. The limestone itself was formed 160 million years ago in the Jurassic period. During those times there was a sea here too, although it must have been much warmer than today. Tropical coral reefs and shallow lagoons provided a rich environment for numerous species of sea creatures and aquatic plant life. Their fossilized remains can be seen in the coastal cliffs of Cape Rea. The Atlantic coast of Agadir provides us with just a small taste of Morocco's ancient past, and it's this past that we're going to explore. Time will take on a completely new meaning, and we'll come face to face with forces of unimaginable violence to which whole continents succumbed. Morocco's oldest rocky witnesses date from the earliest era of the Earth's development. More than 3 billion years old, these rocks record the beginning of a very diverse history. Small continents joining and becoming large ones. Huge rifts opening up. The sea flooding over the landmass only to withdraw later. Temperatures varying between Arctic cold and desert heat. Our expedition will guide you through the highlights of Morocco's long geological history. Concealed in the country's rugged mountain chains are some fascinating snapshots from down the ages. Solidified rock melt from the depths of the ancient mountains. Some of the oldest creatures on Earth. Fleets of squid-like orthoceras. Mysterious mud ridges made of ancient seabeds. Fossilized rivers. Waterfalls. Caves. And gorges that have etched their way into the tropical limestone. Oyster banks from the Cretaceous period. Bizarrely shaped debris fields. And giant wind-blown sand dunes. Much of Morocco is covered in mountains, exposed scars that are testimony to the awesome power of continental collisions. The southeast of the country is dominated by the Anti-Atlas, soaring as high as 2,500 meters. The High Atlas Mountains rise above central Morocco, the Alps of the Maghreb. This mountain chain is 700 kilometers long and touches heights of over 4,000 meters. It remains a formidable barrier. You can count the number of passes through it on one hand. North of the High Atlas is its somewhat smaller twin, the Middle Atlas. And in the far north of the country, the Reef Mountains watch over the straits leading into the Mediterranean Sea. Now we turn back time, more than 500 million years. A trip through time to an era when the continents were empty and lifeless. This is the beginning of our journey through Morocco's stony past, the moment that primeval rocks were created deep in the belly of the Earth. Today, the molten rocks of that era are exposed in the heart of the Anti-Atlas. 1,000 meters up in the mountains, a string of oases stretches around the town of Tafraout. Nature and her tools, wind, temperature fluctuations, and water, have etched bizarre forms into the rocks. The ancient granite dome of Tafraout is surrounded by steep, barren mountain slopes. Within the pink granite are astonishing rock needles, spheres, towers, and sugarloaves. The piled stones look as if they could fall down at any moment. The Chapeau de Napoleon, Napoleon's hat, 2 kilometers south of Tafraout, is the masterpiece of this open-air museum. As hard as granite. The old saying seems not to apply in this case. Granite consists of grains of minerals between which are tiny cavities that make the rock porous to air and water. The grains are made up mainly of the minerals feldspar, quartz, and mica. The water that penetrates the rocks attacks the minerals that are more easily dissolved, feldspar and mica, and causes the granular decay of the granite. But just as important for the formation of the rock sculptures of Tafraout is the regular fracture pattern. The fractures and joints in the granite were formed by cooling and pressure relief in the mountains. The stone was split into blocks, the corners slowly rounded off by nature. Chemical weathering penetrates the rock, and layer by layer, the outer surface of the granite is eroded away, almost like peeling an onion. That's exactly how geologists refer to it, onion skin weathering. The shape of the blocks and the stone statues follows the prevailing pattern of the fracture system. The vertical joints, lying close to one another, give rise to the formation of needle rocks. Square blocks tend to become spheroidal forms. The granite of Tafraout was formed 550 million years ago as several continental blocks collided and Africa was born. High temperatures in the mountain's core led to the melting of the rock in some places. The glowing magma traveled upwards along the fractures, but came to a halt at some depth. The liquid rock solidified and formed large granite domes. Over millions of years, the mountains above were slowly eroded, and today the granite lies exposed on the Earth's surface. Not content to let nature work her magic, Belgian artist Jean Verame decided to make his mark on this landscape. In 1984, he and a group of Moroccan firefighters set to work with 18 tons of blue, red, violet and white paint. Equipped with solar-powered spray guns, they spent 3 months transforming a stretch of granite blocks 3 kilometers north of Tafraout into a work of art he called Les Pierres Bleues, the blue stones. Today, the color is fading, but natural decay is part of Verame's artistic concept. The artist created similar works in the Tibesti Mountains in Chad and in Corsica. Besides granite, there are other stones from the dawn of Earth to be found in the Anti-Atlas, formed in the Precambrian. Schists, quartzites and serpentinites, all taking us a little further into Morocco's distant past. Almost without exception, these old rocks were once buried at enormous depths. The tremendous pressure and extremes of temperature caused the rocks to melt, deform and harden again. It's often impossible to say what the origin of these metamorphic rocks was. They followed a tortuous route and finally ended up at the Earth's surface. The dark Precambrian mountain complexes are like islands, popping up in a sea of rocks from more recent times. Shortly after the granites of Tafraout had been created, destruction of the newly formed mountain chains began. The rubble piled up in the hinterland of the southern supercontinent of Gondwana. Huge river systems cut into the landscape for thousands of kilometers. They carried endless deposits of pebbles, sand and mud, some of which flowed over Morocco as they went. This was the creation of the country's oldest sediments. The detritus of half a continent piled up here, washed up from the furthest corners of Gondwana. Eventually, however, the supply of debris from the large African hinterland faded away. Then a new age dawned, an age of slime. The oldest and most successful organisms in Earth's history took over Morocco. Microbial mats made of colonies of cyanobacteria, masses of them. Fossilized as stromatolites. Today they can be found close to the Tizi-Tinefif Pass in the Anti-Atlas, just as the sea left them behind in ancient times. Large parts of the Anti-Atlas consist of limestone made of these microbial mats. Photosynthesis of the cyanobacteria, the removal of carbon dioxide from the water, led to the precipitation of calcium carbonate on their surface. Layer after layer was deposited and formed the typical layered stromatolite structure. Mud particles were also trapped and incorporated. It must have been paradise, virtually nothing around to eat the stromatolites. More complex life forms had not yet developed in this early phase of evolution. Their worst enemy was the debris washed into the sea by rivers. This regularly covered the slime mats and sometimes killed them off. Some parts of the Anti-Atlas have black stromatolite layers that run across the landscape, evidence of a time when oxygen was in short supply in the sea and foul organic slime covered the microbial mats. A few million years later, and the golden era for the stromatolites was over. The rivers suddenly began to transport so much sediment into the seas that the dominance of the stromatolites came to an end. Now sand, gravel and mud began to pile up in regular layers. Southeast of the city of Ouarzazate in the Tizi-Tinefif Canyon, a wadi has cut deep into this fascinating archive of the Earth's distant past. Geological history can be read layer by layer on the walls of the gorge like a book. Wind and water have sculpted the mountain peaks, transforming them into incredible shapes. The splendid view and the constant flow of tourists seem to have tempted Hassan and Mohammed up here with their pets. On the other side of the pass is the fertile valley of the Dra, a desert river that has its source in the high Atlas, the water of which very rarely reaches the Atlantic. A million date palms line the banks of Morocco's longest river. Fortresses made of red clay, the Kasbahs, were the key to power in the chain of oases. It was from here that the local Berber rulers controlled the trade routes, routes that stretched as far as Timbuktu in the golden days. Steep, strangely layered cliffs enclose the valley, a natural cake made of layers of hard sands and softer clays laid down in the Ordovician period in a shallow ocean. The composition of the sea sediments changed with the rhythm of the fluctuating sea level. But then the sea suddenly began to freeze. Temperatures fell dramatically and a huge ice shield formed over Morocco and the Sahara. It was a glaciation that made its mark in England, Wales and as far away as Saudi Arabia, continental fragments then located close to North Africa. Glacial scratches and grooves from this time can still be found in Morocco. In addition, the enormous power of catastrophic meltwaters washed away some of the sediment layers below. The remnants of this phase of destruction are silent witnesses in the mountains of the tranquil Dra Valley. "200,000 years later, the Ice Age came to an end. The glacial ice thawed, and the huge volume of meltwater caused the sea level to rise about 100 meters. The Ice Age sands were drowned and layers of mud covered the sea floor. But the ocean was sick. The sea floor was lifeless, a foul black layer. The oxygen in the lower part of the water column was being consumed faster than it could be replaced from above. Massive numbers of animal corpses sank from the well-aerated upper layers into the mud. Graptolites. Their colonies produced strangely toothed stems. The harsh environmental conditions in the Silurian period forced the Graptolites to optimize their shape at short intervals and adapt. Today, that quick succession of changes enables us to reconstruct precisely events in this ancient ocean. The Graptolites are a fossil clock, unmatched by any other means of measurement. By looking at their age, scientists have proved that this black goo was deposited at the same time in other countries of North Africa. If you've ever driven a car, you've probably had it in your tank. The organic ingredients of the mud are the rich source of the oil fields in the Algerian and Libyan Sahara, most of which is exported to Europe. When exposed to the air, the organic clay oxidizes with time. Gradually, the black turns into grey, red, and green. Mother Nature's paintings in stone stand comparison with contemporary artists. It's a style defined by a painstaking use of color and unusual patterns. elegant fracture systems, creating artful steps, take them into a third dimension. We take a break in Zagora's sea of palm trees, invited to drink a glass of tea at a wedding, enjoying the balmy night. Come morning, a skyward glance shows that quite a different travel group is passing through the Anti-Atlas and has settled down in the oasis overnight. Like us, our feathered friends leave their resting place about 4 hours after sunrise, the sun's rays warming us pleasantly. Merely increasing our desire to set off, it's the white stork's main motivation on their early autumn journey between their summer roosts in Europe and their winter domiciles in Africa. Lifted by warming thermals, these avian gliders spiral up to a height of 700 meters. They then soar out of the uplift and down at about 70 kilometers an hour towards their ultimate destination. Once the stork's altitude is back down to about 250 meters, they seek another thermal, which will allow them to ascend without much effort. The storks follow this pattern for 7 to 8 hours, covering between 150 and 300 kilometers every day. We're going to remain in the Anti-Atlas for the moment and continue our journey through the ancient history of the Maghreb. A few kilometers beyond the town of Tazarine, a modest ridge rises out of the desert. Mouse grey, half buried by sand dunes. The clock has moved on about 20 million years. The sea still has Morocco tightly in its grip. Oxygen has become a rarity again. The ridge consists of a limestone that takes on a grey-black hue when freshly uncovered. It's a limestone that has made the Anti-Atlas and Morocco famous the world over, and a limestone that can be found in every fossil collection around the world. Embedded within the rock are strange arrowheads, packed closely together, divided into many small chambers. There are millions of them, Orthoceras, or the straight-horned, to translate directly from the Latin. They were squid-like creatures with long, stretched shells. The Orthoceras bear a very close resemblance to the ammonites, except that ammonites have spiral shells. The animal itself lived in the last and largest chamber. The rest served to regulate the creature's buoyancy and could be filled with either water or air to help it rise or sink. Wherever the Orthoceras emerge from the ground in the Anti-Atlas, busy hands are to be found breaking up the rock into more manageable blocks of about 1 cubic meter, the valuable raw material for an amazing range of crafted products. The method of mining in most of these quarries hasn't changed over the last 100 years. Mussels are the order of the day, machines nowhere to be seen. It wouldn't pay for international investors and their expensive machinery to mine these small seams, which is why the process is so much slower. And there's no lack of people needing work in Morocco. Work is scarce, and the need for new jobs is going to become ever more urgent in the future. More than 2/3 of Morocco's population of 30 million is younger than 30. Instead of cranes, the mined stone blocks are pulled over an improvised conveyor made of old pipes and saw blades using a steel rope. The front of the block is raised with a kind of jack, while the steel rope is tensioned with a hand winch. Eventually the block gives and moves a few centimeters forwards, and the whole process begins again. Most of the excavated Orthoceras limestone is transported to Erfoud, the center of the eastern anti-Atlas. Besides the cultivation of dates, many of the 18,000 inhabitants make a living either directly or indirectly from the region's rich fossil deposits. Everywhere you go, people are sawing, hammering, filing and gluing. It's hard work, but people are proud to be part of this privileged caste of craftsmen. The fossils of Erfoud are famous, and if you haven't heard of this town, you'll probably have come across the unique objects made of Orthoceras somewhere. The rock is first cut with saws into smaller blocks. The rough outer layers are removed. Large, thin layers are cut out of the blocks to make tabletops. The serrated edges are smoothed off. The huge Orthoceras begin to take shape. Dust fills the air. With great skill, multicolored varieties of the Orthoceras limestone are pieced together. The center of the tabletop mosaic is decorated with an ammonoidea, a rolled-up relative of the Orthoceras. The workers of Erfoud make more than just tabletops out of the exquisite stone. You can tile your whole bathroom in this exclusive material. That's exactly what many top-class Moroccan hotels have done. Making wash basins requires a lot of concentration. One wrong blow with a hammer, and you've got a second, unwanted drainage hole in the basin. Another popular product are beautifully crafted Orthoceras pillars, a shining and exquisite living room decor. "15 kilometers southeast of Erfoud, a group of mysterious cones poke out of the landscape along the Hamar Laghdad Ridge. Clustered along a narrow strip, 3.5 kilometers long, a total of 48 carbonate mud mounds stick up to 50 meters out of the ground. It's still not clear how the Keskes chain of hills was formed. Despite extensive research, experts still disagree about the mechanism behind their creation. Some scientists believe the cones are shallow sea reefs, and others say they're the remains of deep water mud. What is clear is that 410 million years ago, a volcano erupted on the seabed. Once the volcanic activity had subsided, animal and plant life established itself on the sides of the volcano under the sea: Ammonidea, Orthoceras, and mussels. A new theory suggests that hot volcanic springs on the seabed played an important role in the creation of the mud mounds. These hot springs may have triggered precipitation of finely crystalline carbonate that accreted to form the cone-shaped mounds. Similar mounds were formed in the Devonian period in other parts of northwest Africa, for example in neighboring Algeria. The Moroccan Sea remained firmly in the grip of carbonates for the following 40 million years. A solitary cliff made of marine deposits towers out of the landscape southwest of Erfoud. It's known in geological terminology as an Inselberg, an island mountain, for the way it soars above the surrounding plain like an island rising from the sea. It's made of the hard remains of a mountain that wind and water have been unable to destroy so far, but whose days are numbered. In the colonial era, the military exploited the hollow structure of the Inselberg and built a fort here. A high wall closed off the only access point to the camp. "300 million years ago, the sea was banished from the land. Morocco rose up, and all the deposits were bent and crushed by enormous forces inside the earth. Africa, North America, and Europe collided and became welded together. A massive mountain chain came into being, stretching right across the newly formed supercontinent of Pangaea. Apart from the Anti-Atlas, only a few bits of the former massif are left in Morocco today. The mountains were worn away over the subsequent 100 million years. They collapsed, and huge cracks and basins opened up that quickly filled with red debris. Wind, water, and violent fluctuations in temperature quickly broke down the mountains into their constituent parts, and Morocco saw red. Red stones crashed down from the mountain's scree fans. Rivers and small dunes pushed red sand ahead of them, and red clay settled on the floodplains and in the lakes. The red is rust. The debris contains large amounts of oxidized iron that gives the stone its intense red hue. One of the most impressive red Triassic landscapes can be found in the Argana Valley, 40 kilometers north of Agadir. Just as it did back then, a river babbles through the valley. The cliffs consist of cross-bedded sandstone layers that show the direction of flow in the old river system. Like the wind building sand dunes, so the river constantly adds to the downstream side of the dunes on the riverbed. Layer upon layer, the sand piles on the bottom are extended and the slopes shifted. Eventually, a new underwater dune is created which pours over the old one. No wonder that some of the oldest species of trees are to be found in this landscape. The species, Argana, is at least a third as old as the sandstones upon which these trees grow in the Argana Valley. The oil pressed from its fruit is highly prized by Parisian chefs. Goats appreciate the Argan tree too. They'll even climb them to get to the leaves and fruit. Eventually, this river landscape was reconquered by the ocean. The sea level rose and created a tropical coral landscape. Siliceous sponges formed huge reefs in the warm water. The carbonate sea from the Jurassic period now nestled in a huge rift. Where today the high and middle Atlas tower into the sky, tectonic forces tried to rip apart the supercontinent Pangaea and North Africa. The Atlantic Ocean came into being and did its part to rip the African continent apart as well. Enclosed by steep slopes, the tropical ocean washed into a broad gash through the heart of Morocco, 1,000 kilometers long and 100 kilometers wide. The ancient Atlas Gulf. But ultimately these forces were unable to achieve their goal of splitting apart North Africa. Sometime later, Africa got onto an unstoppable collision course with Europe that resulted in the creation of long mountain chains on both continents, among them the High Atlas. Corals, sponges, mussels and snails, the former inhabitants of the tropical ocean, suddenly found themselves in a huge natural elevator. Now they sit on top of the mountains at an altitude of several kilometers, and in the winter, they're buried deep in snow. Huge gorges cut into the southern edge of the majestic High Atlas. Here, rivers have etched deep trenches into the massif, some of them 500 meters deep. They allow a rare view into the core of this mountain belt. The Gorges de Dades is Morocco's Grand Canyon. Some parts of the gorge are so narrow that the road had to be blasted out of the bare rock. No matter how uniform they may look from a distance, these mountains are far from homogeneous. They consist of a layer cake with alternating hard limestone beds and softer clayey layers that have been cut into to varying degrees. Where the rock is soft, the gorge broadens out into a basin. These valleys were settled and are cultivated by man. But how could the River Dades work its magic on these powerful mountains? When and how were the gorge systems at the southern edge of the High Atlas established? The answer lies in the deeply entrenched meanders, the bends in the river. Shifting riverbeds are usually common to quite different landscapes, lowland plains. So why does the River Dades meander through these mountains and not simply cut a straight path? The river must have existed and created its bends and loops before the High Atlas was created. When the mountains began to form, the Dades was already etching itself into the ground. This meant the river maintained its course and its original meanders despite the creation of the mountains. It did so for many millions of years to the present day. "150 kilometers to the east, there's another large canyon in the High Atlas that carves its way through the Jurassic limestone. Wadi Ziz. This gorge was used as a pass by the Romans, and today it's still one of the most important transit routes across the High Atlas. In a region of steep gorges made of hard Jurassic limestone, waterfalls can never be very far away. And indeed, on the northern edge of the High Atlas, 170 kilometers northeast of Marrakesh, a river plunges in several cascades hundreds of meters down the Wadi El Abid. It is without doubt the most spectacular waterfall in Morocco, the Cascade de Zoud, translated from the Berber language as the Olive Falls. Olive trees are a key part of agriculture in this region. A permanent rainbow hangs over the gorge. The sunlight is refracted in the spray of the plummeting waters. Decorous curtains of calcareous sinter adorn the rocks. Its limestone was dissolved somewhere in the depths of the Jurassic Massif in the High Atlas and is redeposited here. The water loses carbon dioxide in free fall. The chemical balance changes and calcium carbonate is precipitated. At the foot of the Cascade de Zout lies an idyllic natural swimming pool, providing Morocco's children with a first-class bathing spot and a welcome opportunity to cool off. The really brave can try and traverse the watery inferno. A change of location now to the cedar-covered slopes of the Middle Atlas northeast of Khenifra, also Jurassic limestone. These mountains reach heights of more than 3 kilometers. The limestone is full of cracks which allow rain and meltwater to penetrate and run off underground. On the edge of the Middle Atlas, we find old acquaintances from the Triassic river landscape of the Argana Valley. Red-brown clays abruptly stop the water that trickles through the limestone lying above. The water follows the impermeable layer until it emerges at the Earth's surface as numerous springs. Salt crusts mark the spring holes. On its way, the water eats away at salt deposits hidden in the red clays. In some parts of the High Atlas, these deposits are mined commercially. They say that the river Rabia is fed by 40 springs, which is why it's also called 40 source. At 555 kilometers, it's Morocco's longest river. Shadow and a fresh dampness provide a perfect opportunity to rest and relax. A pretty waterfall tumbles down a steep escarpment, in terms of its construction similar to the Cascade de Zout, but not quite as high. Impressive calcareous sinter deposits have formed here as well. And the 40 source is just as good for swimming or washing as its larger brother in the High Atlas. On the northern edge of the Middle Atlas, near the small town of Taza, in the mountains of Jebel Tezeka, lies the answer to the origins of the dissolved limestone freight in the mountain streams. Rough Jurassic limestone peaks surround a broad, shallow valley 1,500 meters up in the mountains. The valley floor consists of very fertile soil. It's known as the plain of Dayat Chika. Up here, the Berbers can live from arable farming and cattle rearing. The valley is what's known as a polya. Acidic subterranean watercourses have dissolved the limestone in the rocks and etched huge hollows into the stone. Bit by bit, the water worked its way below ground. At some point, the massive rock above the hollows no longer had enough support, and the cave system collapsed in on itself. The pattern continued upwards, creating a visible hole in the landscape. Close to the polya, a smaller collapse has left a hole 20 meters wide that leads 180 meters vertically into the deep. It's the shaft of Phreato, a karst doline. Limestone erosion and collapse have created a narrow access to the deep core of the mountain. Firs and moss have populated the opening of the shaft in the damp twilight. It remains cool here even in the height of summer. A steep stone staircase leads the visitors down into the deep darkness. Light barely penetrates down to the floor of the shaft. And this is where the adventurous part of our trip into the underworld really begins. Hidden in one dark corner is a black opening of about chest width, the entrance to an exciting cave tour. The caves were first explored by the French in 1934. Since then, hardly anything about the 270-metre-long subterranean labyrinth has been changed. Dozens of tourists visit the Tafraout caves every day, but there's no such thing as light installations down here. Torches are the only source of light, if they're working. The first stalactites appear out of the darkness. In a similar manner to the limestone curtains of the waterfalls, here too carbon dioxide degasses out of the water as it drips. The chemical balance changes and a small amount of calcium carbonate is deposited. Over many years, long spikes grow down from the roof. The same happens when the water splashes onto the cave floor, creating stalagmites that grow in tower and candle shapes. Just 3.5 kilometers north is the Chica Cave. At a length of almost 4 kilometers, it's one of the largest cave systems in North Africa. Experts believe that the Chica Cave is linked to the Tafraout cast shaft underground. We now leave the Jurassic and move on to another period in the Earth's history, the Cretaceous. A carbonate-rich sea continues to wash over Morocco and forms rocks that are very similar to the preceding period. 25 kilometers south of the town of Er Rashida, water reflects off the walls of a grotto made of chalky layers. The water is from the source Bleu de Mesqui, the Blue Spring. Warmed to a temperature of 18 degrees, it bubbles out of the ground here after a journey from the high Atlas down through the limestone. The spring is the continuation of the Ziz River, the deep gorge which we've already traversed in the mountains. There, the Ziz goes underground and returns to the Earth's surface at this spring. It continues towards the broad expanse of the Sahara, where it eventually dries up without ever seeing the sea. Towards the end of the Cretaceous, the sea had become so deep that the chalks on the sea floor were covered by fine mud. We briefly returned to the blowhole coast near Agadir to study the high cliffs which preserve millions of years of Earth's history. Lenses of limestone wind their way through the clay. Iron-rich solutions created interesting mosaics along the cracks. Hidden in the marine mud are witnesses to rich nutritional environments, but also the lack of oxygen. During some phases, the oxygen levels in the Cretaceous ocean were so low that a dirty black goo formed on the sea floor. Only in the upper water layers and the stirred-up coastal zone were there signs of life. It was home to microscopic creatures made of calcium carbonate, the Foraminifera. They were sophisticated architects, fashioning their shells into the strangest shapes. At one point, there was a brief improvement in oxygen levels, and huge banks of oysters settled the ocean floor. The debris was piled meter high. Today, 90 million years later, the oyster shells are again washed by ocean waves at high tide. You have to look a little closer to realize that these artfully shaped coastal inhabitants are actually million-year-old fossils. 70 million years ago, towards the end of the Cretaceous, the sea gradually receded. Rocked by large earthquakes, the seabed was slowly lifted up. Then, 25 million years ago, it all began to happen at once. Africa collided with Europe. The Straits of Gibraltar found itself in the center of a tectonic battlefield. The rocky layers of Morocco and Spain were stuck between the continents, as if in a clamp. They had nowhere to go, neither down or sideways, and the only direction they could go was up. The rocks were lifted several kilometers. Thus, the High and Middle Atlas and the Reef Mountains were born. Morocco had entered turbulent times. The high pressure in the mountains heated the rocks deep in the crust to such an extent that parts of it began to melt. To escape the pressure, the molten rock found ways to seep to the surface. The result was a volcanic landscape, like here at the Paysage d'Ito in the Middle Atlas. Six-sided basalt columns, whole batteries of them, like organ pipes. They were formed as the lava cooled. Long shrinkage cracks formed vertical to the cooling surface, leading to the creation of the typical pillar shape. Shortly after the birth of the Atlas Mountains, the process of weathering and erosion began. Water, wind, and changing temperatures began to break down the mountains, reducing them to small pieces. The debris formed huge fans. Streams transported the chiseled pieces downhill in large amounts. In the mountain valleys of the High Atlas, parts of the debris hardened. But here again, the forces of nature got to work, sculpting elegant structures out of the debris. This is how the imposing cliffs of the Amazfran, located in a remote part of the High Atlas, were formed. Today there are still villages here that can only be reached via footpath. The wall of the Amazfran rises 500 meters up out of the wooded slopes of the wadi. Early travelers dubbed the cliffs here La Cathédrale because of the resemblance of its shape and walls to the facade of a Gothic church and bell tower. Erosion has etched slim pillars and natural ledges into the walls, blessing the huge rock dome with a graceful exterior. There are similar works to admire on the south side of the High Atlas. Huge forces must have operated at the entrance of the Dardes Gorge. The strata soar vertically into the sky. In the final phase of its elevation, the High Atlas rolled over its own debris. The high pressures in the mountains have created an impressive fracture pattern. Of course, Mother Nature wasn't going to leave the raw material unadorned and carved beautiful forms out of the gravelly sand. Huge figures stand sentry over the valley. Many-fingered hands hold the mountain slopes tight in their stony grasp. Or are they chimneys, towers, or even mushrooms? The end product of these destructive forces is quartz sand. Billions of these grains are now blown about the deserts of Morocco and piled up into huge sand dunes. "50 kilometers south of Erfoud, near the oasis of Merzouga in the Anti-Atlas, is the migrating dune of Erg Chebi, towering 100 meters from the stony plain. It's the largest dune in Morocco, over 30 kilometers long and up to 10 kilometers wide. Erg Chebi is only a taste of the gigantic sand dune systems that dominate the Central Sahara in neighboring Algeria and Libya. And so our journey through time comes to an end. We've reached the present. Modern Morocco is a feast of lively colour, transfixing the traveller. But the rocks upon which this impressive country is built go back many millions of years. Their history is diverse, their story narrated chapter for chapter in the breathtaking landscapes of modern Morocco.